So today we're going to be involved in scenarios in which we have a tangent line and a secant line, a tangent line and a tangent line, or a secant line and a secant line. And they're going to be connecting at some point externally, creating an angle when the two lines intersect each other. And there's a formula that allows us to find what that angle is. And the formula involves finding the difference between the major arc and the minor arc. So let's go ahead and look at an example when it comes to a tangent and a secant line. So if a tangent line and a secant line intersect in the exterior of the circle, so outside of the circle, these two lines intersect each other, then the measure of the angle formed is half the difference of the measures of the intercepted arcs. So what does that mean? Let's just draw a picture. So here we have a circle and we have tangent line CD coming through and cutting, or not cutting, just kind of brushing up against the circle there. We have our point of tangent C at D, and that line is crossing through this external point C. Then we have a secant line, we can call this secant AB, cutting through the circle at 2 points, and we see that line also goes through point C. So at point C, we have both the tangent and the secant intersecting, and it creates an angle. So I'm going to call this angle 1 here. So how do we find the measure of that angle? The way we find the measure of that angle is we take the major arc. And when I say the major arc, the bigger arc of the two arcs, we see that if we were to connect A to D, that would be a big part of the circle there. And we subtract the little minor arc where the two lines intersect, which is BD. So once we subtract those, we take half of it. Let's look at an example. Example 1 says find the measure of angle 1. So we have tangent line PS here, and we have secant line QR, and we can see QR and PS, they intersect at point T, that measure of angle 1 that we're looking for. So what do? We're going to take the big angle, that 174. We're going to subtract the minor intercepted arc there, which is 98. So we're going to say 174 minus 98 is 76. Half of 76 is 38. So the measure of that angle 1 is 38 degrees. Let's look at a second example. This one says find the measure of angle 2. So we have tangent line AB, and we have secant line CD, and they intersect at that external point of B, and that's where we find angle 2 just hanging out there. So how do we find the measure of this? Well, we're going to do the major arc minus the minor arc. And by the major arc, I just mean like the bigger one, the bigger arc, the bigger intercepted arc minus the smaller intercepted arc. So we're going to say DA minus CA, or 105 minus 43. 105 minus 43 is 62, and half of 62 is 31. So the measure of angle 2 is 31 degrees. So what we just talked about was what would happen if we had a tangent and a secant line. So now I want to discuss what would happen if we have two tangent lines. So if we have two tangent lines intersecting in the exterior of the circle, then the measure of the angle formed is half of the difference of the measures of the intercepted arcs. So again, here's our circle. We have two tangent lines. We have tangent line CD and we have tangent line AD. Notice they're just two lines that just brush up against the circle there. And then we have two intercepted arcs that are connected between the A and the C. We could do the major arc ABC, and then we can also do the minor arc, which is just AC. So what do? To find the measure of this angle, this external angle here at point D, we say the major arc, the ABC, minus the minor arc, AC, and then we take half of it. So let's look at an example. Example 1 says to find the measure of angle 1. So here we have tangent line WX and tangent line WY, and they're both just brushing up against a circle. So we have two tangent lines there. So we want to find the measure of this angle 1. Well, what's the major arc? The major arc here is 228 degrees, and the minor arc here is 132 degrees. So we would say 228 minus 132. 228 minus 132 is 96. We divide that by 2, and we get 48. In example 2 here, we have tangent line UT, and we have tangent line VU. Creates this angle at the external point U, angle 2. We want to find the measure of that. Now, here's what we need to note. We were only given 120 degrees. We were only given VT, but we need VWT. Well, what do we know about the entirety of a circle? We know that the entire circumference of a circle is 360 degrees. All the way around the circle is 360 degrees. So if we know that VT is 120, we can find VWT by saying 360 minus 120, because in this case, with the two tangent lines, we're looking at the entire area around the circle there. So we have 360 minus 120 is 240, so the major arc distance is 240 degrees. So we would say 240 minus the minor arc 120, so 240 minus 120 is 120. Half of 120 is 60, so we know the measure of angle 2 is 60 degrees. The last scenario that we're going to discuss is if we have two secant lines. If two secant lines intersect in the exterior of the circle, then the measure of the angle formed is half the difference of the measures of the intercepted arcs. So we have a secant line AB here, and we have secant line DE, and they continue through the circle because that's what secants are defined as, and they intersect at point C. So we have this angle, angle 1 here, that's being formed. We have two arcs. We have EA and we have DB. Which one is the bigger of the two? EA is the bigger of the two than DB. So we would say EA minus DB. Now I just wanted to point out here that EA and DB would not add up to 360 because we see that the arc DE and arc BA, they're not being included in this equation. So a chunk of the arc of the circle is not being included. Whereas with the two tangents, because they just brush up against the circle, we're dealing with the entirety of the circle. But in this case, no, that's not it. So let's look at an example. In this example, we see we have secant line TW and we have secant line UV. And those secant lines reach out past the circle and they intersect at point X outside of the circle. We're going to call that angle that's formed angle 1. So what do we see here? We have the two intercepted arcs. We have VW and we have UT. We see that VW is the larger of the two, so we would say VW minus UT, and then we're going to take half of that. Or in this case, we would say 97 minus 33. 97 minus 33 is 64. Half of 64 is 32. So the measure of angle 1 would be 32. Let's do one final example, and this one wants us to find the measure of angle 2. We have secant line NP and we have secant line LM, and we can see those two secants cross through the circle, and as they continue out, they intersect at point O externally. We're going to call that angle, angle 2, where they meet. And what intercepted arcs are formed? Well, we can see that intercepted arc MP is formed, and we can see intercepted arc LN is formed. So we would say the larger of the two MP, which is 80, minus the smaller of the two LN, which is 26. So we would say 80 minus 26 is 54, and then half of 54 is 27. So the measure of angle 2 is 27 degrees. So what's the overall process here? Every time you have lines intersect, whether it's a tangent line or a secant line, you are going to have intercepted arcs created from the points where they touch the circle. You're always going to take the larger or the major of the two intercepted arcs and subtract the minor of the two intercepted arcs and then divide by 2.